Hi everyone. The goal of this video is to look at the three different forms of quadratic functions and learn how to graph them from any given equation. So in number one, we're given this quadratic. It's in vertex form, and we're going to use this to sketch a graph. So first thing you need to know is that vertex form is the most useful form to finding the vertex. That's why it's called vertex form. Okay, now vertex form should look familiar based on our conversation about transformations. So really this is a parabola like y equals x squared, but it's transformed by being shifted to the right 3, being shifted up 4, and then this -1 essentially multiplies all the y values by -1, which will make any y value up here go down here, so on and so forth, which means it will reflect over the x-axis. Okay, so with that said, how do I graph an equation in vertex form? Okay, in vertex form, you can see the vertex. The vertex comes from two things. The x-coordinate comes from right here, and the y-coordinate comes from what's on the outside. Because remember, if we have the parent function y equals x squared, okay, the vertex of that would be 0, 0. You don't have to draw this, but it would look something like this. Okay, and all those points get transformed based on these numbers. So even this vertex starting at 0, 0 has now gotten transformed by moving to the right 3, 1, 2, 3, and up 4. Okay, so the new vertex has moved from here to here. Now, this -1 won't affect the y value here because what you were transforming was 0, 0. If you multiply -1 by the original y coordinate of 0, it won't change that point. Okay, so our new vertex is here, which means you can get the vertex just by looking at this form. This point is 3, 4. Okay, so from vertex form, this is the x-coordinate of the vertex, this is the y-coordinate. Remember, the x always does the opposite of what you see, because it's in terms of y, not x. So from vertex form, you can find the vertex. Now what this -1 is going to do is it's going to reflect over the x-axis. So I know my parabola is going to look something like this. Okay, now that's a rough sketch. I could get a more accurate sketch by making a table, but we'll pause on that for now. Vertex form in general always looks something like this. Y equals a times x minus h squared plus k, where hk, h comma k is the point, is the vertex, which you saw from that example. And it all has to do with transformations. So I want to point out that I'm really not teaching you anything new. I'm just applying transformations to learn about what vertex form is. Okay, we're going to go on to part B. We're going to expand the equation in vertex form to convert the equation to standard form. So when I say expand, I mean we're going to square x minus 3. We're going to multiply by -1, then we're going to add 4. Right, so in order of operations, you do exponent, then multiplication, then add. I'm actually going to pause the video while I do that. I want you to do this on your own in this space here. So again, square this, multiply by -1, add 4, and you should get something that looks like standard form. We'll talk about when we come back. Okay, if expanded correctly, using our knowledge of multiplying binomials from previous units, you should get y equals -x squared plus 6x minus 5. If you did not get that, please go back through my work, check your own, and figure out where your mistake is. Okay, this form here is called standard form. It's useful for a few different things that we're actually not going to talk about in this video, but oftentimes when you see a quadratic, it'll be in its standard form. Okay, so with that said, to summarize, standard form always looks like the following. Y equals ax squared plus bx plus c. Should be familiar. Maybe reminds you of the quadratic formula, which we'll get to through this chapter. Okay, so we're not going to graph the function using anything from standard form, but we are going to convert standard form to factored form by factoring the equation. So factored form comes from factoring. And we're going to do this to find a few other elements to make our graph a little bit more accurate, which we'll see in a second. So we're going to factor this from standard form, and you can convert from vertex to standard to factored. This last step we're going to factor. If I'm going to factor this, I'm going to go through the factoring flowchart. So I'm going to start by saying, can I plot a GCF? Okay, now there's no number in front of the x. Well, there is. It's a 1, which most people would say there isn't a GCF, but there actually is a negative in front of the x squared, which makes it a -1, which I'm going to actually factor out. So my leading term here, that x squared, is positive. And if I factor that out, I have -1 times x squared will give me -1x squared. -1 times -6x will give me a positive 6x. -1 times what will give me -5? It would have to be a positive 5. And now I know that I have 3 terms here, 1, 2, 3. So the best method here would probably be guess and check or AC method. I recommend guessing and checking. So I'm going to set up my parentheses. Whatever's in the first blank has to multiply to be x squared, which has to be x and x. In this last blank would multiply to be positive 5, which there aren't very many factors of 5, so it's going to have to be 5 and 1. The key is what are the signs. So it has to multiply to be positive 5, but add to be a negative 6. So to multiply to be positive 5, they can both be positive, or they can both be negative, but they both have to be negative because they add a negative 6, which if you're going to guess, you should always check. X times x gives you x squared. Minus 5x minus 1x will add to be minus 6x, and minus 1 and minus 5 will multiply to be positive 5. Okay, so this is our quadratic in factored form, and it's called factored form because you can get it by factoring. Another reason why it's called factored form is because from factored form, you can get the factors of the graph. Factors. Factors is another word for X-intercepts. Another word for that would be zeros. So factored form will help us get the X-intercepts, which will help us graph even more accurately. And before we actually find the X-intercepts, I want to summarize what factored form looks like. Okay, so factored form will look like it was factored. You might have some number outside the factors here. That is our A value. Then you'll have some sort of factored form, which I'm just going to use P and Q to represent our factors. Okay, so that's what factored form looks like in general. Now, in terms of how you use factored form, this is interesting because you actually know how to find X-intercepts. Okay, all X-intercepts, regardless of where they are on the graph, would have a Y value of 0 because you're not moving up or down on the Y axis. So with that said, if you want to find the X-intercepts or the factors, you would want Y to be 0. So I'm going to write that out, and I'm going to substitute 0 for Y. So I'll have 0 equals negative 1 times x minus 1 times x minus 5. Okay, now essentially you're solving for x because when you're solving for x, you're solving for the x values when y is 0. Okay, so to solve, you could divide both sides by negative 1, which will actually just cancel out that negative 1. Not that the negative 1 is insignificant, but usually what winds up happening is that number outside is insignificant in finding the x-intercepts. It's significant for a different reason. Which you should know from transformations, what that negative 1, right, same negative 1 is up here, what that negative 1 does to the graph. Notice the A value on all of these, there's a 1 out here, that negative 1 kind of stays the same. That's important, and we'll talk about that if you have any questions later. Anywho, back to this. So now you have 0 equals x minus 1 times x minus 5. How do I solve for x? You should have heard of a property called the zero product property before, and I'm just going to review it right now. Okay, so right now it says the product of two factors is 0. In order to have something being multiplied equaling 0, either one of the factors has to equal 0 or both have to equal 0. Okay, anything times 0 is 0. So one of these two things would have to be 0, and in this case there are actually two options. So the question is, what would make x minus 1 equal to 0? And what would make x minus 5 equal to 0? So solve these equations, add 1 to both sides, you get x equals 1. Add 5 to both sides, you get x equals 5. Which makes sense, because if you plug in 1 here, you're going to get 1 minus 1, which is 0. And 0 times anything will equal 0. Or if you plug in 5, you get 5 minus 5 equals 0. And 0 times this, again, will be 0. Okay, so these are actually your x-intercepts, because they're the x values when y is 0. So we have x-intercepts at 1 and 5. Which I would graph here, and maybe I should erase the other ones that I sketched. Oh, I was close, but not quite when I sketched it originally. So this will help us make it more accurate when we are sketching quadratic graphs. Okay, so there are a few different forms to look at quadratics. You have vertex form, which is really helpful to finding the vertex. You have standard form, which is the standard form. Right now it doesn't seem helpful, but it is helpful in other contexts. Usually we convert to factored or vertex form, and factored you can find the x-intercepts. Okay, so lots of forms, they're all useful, and I think the most important thing to note is they're all equivalent, right? So I started with the vertex, okay, then I multiplied it out to get standard, then I factored to get factored. It's just all different ways of expressing the same equation, but they're all helpful in different ways. If you have any questions, please bring them to class, and have a good night.